Okay, so hello everyone. So in this video, I feel like now, that we've done sequences in series, we've done trig functions, we've done everything we need to know for precalculus, or for calculus, excuse me. Most of everything, so now we're finally just going to do an entire review before we go into actual Cal 1 material. This is honestly the final, it's honestly the final thing that I'm going to do for, the kind of the final video. And, of course, I will continue doing, in the future, I will continue doing more videos on algebra if there's, if anybody requests more videos on certain topics in algebra or in trig or in precalculus. But as far as in order for calculus, basically, this is kind of I'm just gonna do a very brief review, and I'll try to go as fast as I can, because we've already seen all of this in algebra and precalculus. So this is honestly, yes, it is kind of intro to calculus, but it's, honestly, it's just kind of making sure that we understand everything that we learned from algebra, from college algebra to precalculus. So let's get started, okay? So it says true or false, and honestly, these are kind of, I'm just gonna explain each and every one. So number 310, since this is mostly, like what is it called? More of an open-ended response. And I can actually draw a, and let me actually, give me 1 second, guys. Okay, sorry about that, guys. I know it kind of paused a little bit because I was typing this. So let me, so let's get started. So the first, okay, so let me actually, hold on. The first problem in this review exercise for chapter 1 says a function is always 1-to-1. Now, let's write that down. Now, that is true, and that is because basically a function, remember that any function that we have, it doesn't matter what kind of function it is. Let's say we have this curve, it's always going to pass not the horizontal line test, the vertical line test, excuse me. So yes, it is 1-to-1. That is true, because it always passes. There's always one y value for every x value, right? F of g versus g of f, f of g equals g of f, so this is number 311. So let me go ahead and put 311. Excuse me. So basically it's asking whether or not this is true. So basically, does f composited of g of x equal g composited of f of x? So let's do an example, okay? Let's pretend we have f of x equals 3x, or actually, hold on, x minus 1, and let's pretend g of x is equal to x squared. I'm just going to say x squared. Now, we're going to do f of g of x, f composited of g of x, right? This is going to be the quantity x minus 1 quantity squared. And then g of x, this is g composited of f. So basically this is going to equal, if I do my, so let's color code this. This is equal to f of g of x, okay? This is f of the quantity x squared, right? This is going to be equal to, and that means for every x value in f of x, I'm going to put x squared, okay? So it's going to be the quantity x squared minus 1. This is f composited of g of x, okay? I know it looks like a little O, but it's composited, like f composited of g. So that means that f of g of x equals x squared minus 1. And what this is asking is if f of g of x is this equal to g of f of x. And basically, is this true at all? Is this theorem true at all? And so we're going to do g of f of x to see if we get the same exact thing we got over here. So we're going to do g of, so now we're going to do g of x minus 1, okay? This is going to equal to the quantity x minus 1, or let me actually, hold on, x minus 1 quantity squared. So this is equal to x squared minus x plus 1. This is equal to x squared minus 2x plus 1. So are these two identical? If you think about it, are they the same thing? If I say for example, like, are they an identity, basically? So if I plug in 2 for x, can I say 2 squared equals, or 2 squared minus 1 equals 2 squared minus 2 times 2 minus 1? If I say 4 minus 1, is that going to equal to 4 minus 4 minus 1? 3 is equal to 0 minus 1. 3 equals negative 1, which is not true. So therefore, this is false. This is so f composited of g of x does not equal g composited of f of x. So in the textbook, it would be false, okay? Now it says a relation that passes the horizontal and vertical line test is a one-to-one function. That is only true if it passes I believe if it only passes the vertical line test. If it doesn't pass the vertical line test, so for example, if, for example, let's say I have something like this, right? Or I don't know, let's say I have something like that. We're just gonna put it like this, right? Let's say this is f of x, and a one-to-one function means that for every x value, there is only one y value. What does that mean? That means that for every x value, let's say we have an x over here, there's only going to be one value in which that crosses. So this is why this goes with the vertical line test. Okay. That is what a one-to-one function is. It does not have to follow the horizontal line test. So this one would be it would be false, because it would only have to pass the not the horizontal line test, the vertical line test. Okay. Now for 313, it says a relation passing the horizontal line test is a function. Okay. So that is not true, because in order for it to be a function, it has to pass the vertical line test. So for example, if I have something like this, or I don't know, let's say, for example, let's say I have a circle like this, right? And I do vertical line test, and you see that there are two x values for one x, or two y values for one x value. Let's say this is x0, x1, x2, x3, x4, x5, dot, 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 dot. So, there are two y values here. Okay, so no, it would not pass the, so basically, which one was it? It was this one. It passing the horizontal line test. If I said, so basically, okay, that's the vertical line test. If it's horizontal, I mean, again, in order for it to be a function, it has to pass the vertical line test, not the horizontal line test. The horizontal line test would only be if the function has an inverse, okay? Now, it says for the following problems, state the domain and range of the given function. So, so state the domain and range. And let's say we have f of x. Okay, give me 1 second, guys. I'll be right back. Okay, guys, I'm back. So, in this next part, what we're gonna do is, it's the state, domain, and range. So, we already know, obviously, and this is from, it's something that we should already know, that in a parabola or in a quadratic function, anything that, basically the domain, there are no restrictions on the domain. So the domain is from negative infinity to infinity. You should know that already. And because obviously when you do the graph, there's no restrictions. X can be anything, right? And the range is just whatever. So basically, it is from, so to find the range, we have to find the vertex. So to find the vertex, we do -2 over, so it's negative b over 2a, right? X equals negative b over 2a. So it's -2 over 2 times 1 This cancels out. We get negative 1 over 1, which is just negative 1. We plug it back in on our function. We get 1 minus 2 minus 3. This is negative 1 minus 3. This is negative 4. So our vertex is negative 1, negative 4. So that means that because the vertex is negative 1, negative 4, basically the range can only go from, because obviously when we do the graph or we do the parabola, it's going to go, let's pretend that the graph is like right over here or something like that. And this is the vertex, negative 1, negative 4, right? So the range can only go from, and it's going to be a bracket, negative 4 up to infinity. Because the graph is facing up, and it's the a value is greater than 1, it's facing up. So it'd be negative 4 to infinity. Now this one, g of x equals ln of x minus 5. So g of x equals ln of x minus 5, what we're going to do, we know that when ln, so ln of e equals 1, ln of 1 equals 0, and ln of 0 is undefined. So we have to do, what I'm trying to say is that x minus 5 has to be greater than 0, okay? Now, the domain would be, so it'd be all real numbers such that, or rather, such that x is greater than 5, and that means that basically we're going to go from negative infinity to 5, and then it's going to go union 5 to infinity, okay? And actually, hold on, it would be, actually, so, what is it called, the function, if we, so basically we know that the domain has to be greater than 5, and if it's less than 5, it's not going to be defined. So in reality, the domain is going to be from 5 with a parentheses to infinity. Okay, and then the range is going to be, so let's see, it would be, I'm trying to think about this one because I always kind of forget the shape of a what is it called? The shape of natural log. So basically, I know that natural log of x at so basically at x equals 6, so 1, 2, 3, 4, 5, 6, it would be going something like this. Let me actually, hold on, give me 1 second, guys. So if you think about it, at x equals 6, the function is going to be 0, right here. This is x equals 6. At x equals 5, it's not really going to reach 5, even though it kind of looks like it does. So the domain is going to be from, so basically it's going to be from 5 to infinity, not including 5, okay? And yes, That's what it would be. So that is the domain of this function, and then the range would be, I believe that it would be from negative infinity to infinity. Yes, negative infinity to infinity. Okay, and then for part C, it says h of x, so h of x equals 1 over x plus 4. Now the domain is going to be all real numbers such that x does not equal negative 4. So in reality, we're going to do negative infinity to negative 4, not including negative 4, union negative 4 to infinity. Okay. The range is going to actually be whatever the horizontal asymptote of this function is. Now, this means, so basically we know that 1 over x, if we look at the function 1 over x, the horizontal asymptote is y equals 0, okay? Now, because this is kind of similar to this one, where it's x to the 0 over x plus 4, if we look at these two parts, it's going to be the degree of the numerator is less than the degree of the denominator. So the horizontal asymptote is also y equals 0 for this one. So in reality, if we do a little sketch, you know, it's going to go, the range is going to go from, we have, I believe it goes something like this. So this is negative 4, and I'm trying to think really quickly. It should go something, so it should go something like this. So right, that's what it should be, because this is the vertical asymptote. Let me actually kind of draw the curve a little bit better. This is the vertical asymptote, and the horizontal asymptote. And I know it's not perfect. This is just a rough sketch, but you see that it's approaching 0. So the range goes from negative infinity to 0 union 0 to infinity, but we're not including or actually, hold on. Are we including 0? No, we're not including 0. We're not including 0 on this one, because that's what the horizontal asymptote is. It's y equals 0, so that means that the graph can never reach it, right? So that's the domain and range for this one. Okay. Let's see. And let me, hold on. Okay. Okay, well, we did f, g, and h. We did the domain and range of those functions, so that's good. Now we want to do h of f of x. So h of x, we know that h of x, so the other one, number 316, says h composited of f of x. They want to know what is h composited of f of x. And let me actually, hold on. So h of x, we know h of x is equal to 1 over x plus 4. And f of x equals x squared plus 2x minus 3. Now they want to know what h of f of x is, right? So we have to do h of f of x, okay? That's what that is. And so then you're gonna do, so basically you're gonna plug in f of x for all x. So basically it's gonna be something like, let me just kind of color code this a little bit. In reality, you're gonna do something like this. So basically it would be something like this, right? And so basically you're gonna do 1 over, and f of x is x squared plus 2x minus 3, so you're gonna do x squared plus 2x minus 3, and then add 4. Right, so you have 1 over x squared plus 2x minus 3 plus 4. Okay, so we're going to have x squared plus 2x minus 3 plus 4. Then this is going to be 1 over x squared plus 2x plus 1. You can also write this as 1 over x plus 1 quantity squared, okay? At this point in calculus, you're supposed to know how to do, how to do sum of two, like basically how to factor polynomials, okay? Because in reality, you do that a lot in calculus. Okay, so that's what h of f of x is. So that means that so basically h composited of f of x equals 1 over x plus 1 squared. Okay, so like this. All right. And then they want us to do and then they want us to find the what is it called? That's interesting. Well, we'll do the domain of this. So the domain of this would be from negative infinity to negative 1. Yes, to negative 1 union negative 1 to infinity, because we can't make x plus 1 equal to 0. So x plus 1 cannot equal 0, so it would be all real numbers such that x does not equal negative 1. So the domain would be negative infinity to negative 1 union negative 1 to infinity, not including negative 1, which is why there's a parentheses here, okay? The range would be, so again, if we rewrite this as x to the 0 over x squared, and you can look at the function of 1 over x squared, or you can kind of sketch it a little bit, but basically it looks something like this. Okay, this is 1 over x squared. At least I think it is. Give me 1 second. 1 over x squared. Yes. So as long as you remember how this looks, then you're good. Or you can also do, I'm trying to think. You can also do 1 over x. So anytime you have x to the n over x to the m and n is less than m, then you can say that that's the range, or rather, well, not the range, but that the horizontal asymptote is or that there is no horizontal asymptote. At least I think that's what it is. Just give me 1 second. Or actually, I'm wrong. It would be y equals 0. The horizontal asymptote would be y equals 0. So then that means that basically this, in reality, because the graph is looks this way, so let me actually, give me 1 second, guys, hold on. Okay, so this one's a little tricky. In reality, the graph, I mean, I would kind of remember how this graph looks, but it would look like this. And that means that the range would go from -infinity to 0, like this, union 0 to infinity, like that. So that is what hold on, give me 1 second, guys. I'm looking. So -infinity. Actually, I'm wrong. Oh my goodness. This one's tricky. So it would go from 0 to infinity. That's what I mean. From 0 to infinity, and yes, that's how it would go. It would go from 0 to infinity. This one's a tricky one. I won't lie. This one's a very tricky one. It's a little bit difficult. But anyways, so let's see. And then that was h of f of x. Now we want to do g of f of x. So g of f of x. So that's number, what number is that? Number 317. So g of f of x, that would be ln, so it'd be, hold on, it'd be ln of, so we know that g of x equals ln of x minus 5, f of x equals x squared plus 2x minus 3. And g of f of x would be g of x squared plus 2x minus 3. Saying you're going to plug this in for x, okay? Actually, hold on. It would be 4, so in reality, it would be 4. It would be for this part. Okay. So then this would be ln of the quantity x squared plus 2x minus 3 minus 5. This is equal to ln of, or natural log of x squared plus 2x minus 8. And then the domain, or the, what is it? What did it say, the domain and range? Yes. The domain and range of this. So the domain, obviously, like we said, now the only thing about this one is that, like I said, maybe it's best to graph these because, I mean, we can do, so basically, we can set this, oh, what can we set it to? It's basically, greater than 0, because 0 is undefined at like if this were to equal 0, basically. And so we would say x squared plus 2x minus 8 is greater than 0, and we would how do I say it? We would factor this out, so this would be x plus 4 times x minus 2 is greater than 0. And then to solve this, we would go from negative infinity to negative 4 and then to 2. So then we're going to just test values. So if we do negative 5 plus 4 times negative 5 minus 2 is greater than 0, is that greater than 0? So basically you do negative 1 times negative 7 is greater than 0. 7 is greater than 0, so yes, this works. And then we do between negative 4 and 2, so it'd be 0 plus 4 times 0 minus 2, is that greater than 0? It'd be 4 times negative 2. Negative 8 is not greater than 0, so this part can't work, because it's negative, right? And then from 2 to infinity, we can plug in 3. So if we do 3 plus 4 times 3 minus 2, is that greater than 0? It's basically 7 times 1 is greater than 0. 7 is greater than 0, so yes, this works, because this is positive. So basically, the domain of this would be, let me actually, hold on. Okay, so the domain of this, and I'm trying to see exactly how I'm doing this, because it's a little bit tricky. So, okay. That means that basically, oh my, and this one's a little bit, this one's kind of difficult, because you have a squared function inside the parentheses of the natural log. Okay, so in reality, the domain of this would be, let's see. Okay, so this is a very interesting function. I would use a graphing utility to do this, only because in reality, we don't know. I mean, you can sketch the function, but because we don't know, how do I say it? Because we have this part going on, and then we also, it's not just that, but it's also in terms of natural log. It's a little bit complicated to do it without, like, to do it by hand. You know what I mean? So in reality, the domain of this function would be, so let's see here. Give me 1 second. So if we just kind of look at the graph, really, and it's like I said, this one is a little bit difficult. It looks something like this, but as you go down, it is undefined for, let's see, give me a second. It is undefined for those two x values that we were talking about. So basically, it is undefined between, I believe between negative 4 and 2. So it's undefined between negative 4 and 2, right? And basically, for example, at x equals -4, there's no actual, like, what I'm trying to say is there's no, it's not defined. And, but, so basically the domain is going to be from -infinity. This one's a little tricky. It's from -infinity. Oh gosh. -infinity to -4, parentheses, because it's not including -4, union, and then, let's see here. And it's also not including 0 because, or even like anything greater than -4, because like right here, in this part of the interval, it's negative, and we don't want negative inside of our natural log, right? Because then if it's negative, it's going to be undefined. So we're not including anything between -4 and 2. So it's going to be union 2 to infinity. Okay, it's tricky. It's tough. This one's a little tough. And then for let's see. Give me a second. For the range, so if you think about it, for the range, I'm trying to think exactly how to do this part. For the range, basically, so obviously, just looking at this, I mean, I don't, in reality, maybe it does have a what is it called? So the range would be from, it does have a range. It definitely does have a range. We're just going to go ahead and skip this one. This one's really difficult because I'm not exactly 100% sure. But as long as you understand that how to find the domain and range between these three functions, that is really what matters here. The composition of functions is a little more difficult, but as long as you understand how to find the domain and range of rational functions, quadratic functions, and natural log functions, okay, or logarithmic functions. That's really all that matters. Let me see, hold on. Okay, so for this next part, it says find the degree, y-intercept, and zeros of the following polynomial functions. Now, this one, so the degree, obviously the degree of this function is the highest exponent. So the one that we're starting with, the highest power of x is what it is. Okay, so the degree of this one is 2. Okay. Okay, so the y-intercept and then the y-intercept. So the degree is 2 because it is the lowest term here. Okay. The y-intercept is going to be, so basically you're going to set x equal to 0. So that means that f of 0 is 2 times 0 squared plus 9 times 0 minus 5. You're going to have 2 times 0 plus 0 minus 5. This is 0 plus 0 minus 5. So this is 0 minus 5 is -5. Okay. So the y-intercept, and I know some teachers or some professors do it as like, they do it as, like they would say y equals -5. But I like to do it as a coordinate, 0, -5. That's just my preference. I mean, the way that you say it is the y-intercept is 0, -5. the y-intercept occurs at y equals -5, you know? It's about how you word it. So, let's see. But you would have to know, like, if the professor or the teacher wants you to write it in coordinate form, it would be 0, -5. Anytime we have a y-intercept, it's always 0, c. That is if we have a graph, and this is anywhere over here is c, right? And over here too, if we have a b or -b, whatever, the x-intercept would be b, 0. But anyways, and then it says to find the zeros of the polynomial. So this one is 2x squared plus 9x minus 5, and we want to find the zeros of this polynomial, right? We can factor it. So the zeros would be, if we do our x box, 2 times -5 is -10, and then we have our b value is 9, so then it would be two values that multiply to -10 and add to 9 are -1 and 10. So then we have to do our box here like this, and this is always the ax squared term, so it's going to be 2x squared, and then we have -x, 10x. So let me actually do this again. 2x squared, -x, 10x, and then -5, because these two are just these two parts, like this, and then this over here. So then we have, so it'd be x times 2x, and then 5 times 2x, and then it'd be x times -1, and then 5 times -1 is -5. So then the zeros would be such that the zeros occur at 2x minus 1 equals 0, and x plus 5 equals 0. Right? And then you would say, you would add 1 on both sides, you get 2x equals 1. Divide by 2 on both sides, you get x equals 1/2. And then minus 5, you do x equals -5. So this would be another 0. So the zeros are as follows: x equals -5 and x equals 1/2, excuse me. Okay, and then for number 319, it says to do the same thing for number 319. So 319 says, so it's x cubed plus 2x squared minus 2x, right? So f of x equals x cubed plus 2x squared minus 2x. And then, okay, and then you have, so to find the degree of the polynomial, again, like I said, it's the highest power of x, so the degree here is 3, and then the y-intercept would be such that all values of x are equal, or basically x equals 0. So we have 0 cubed plus 2 times 0 squared minus 2 times 0. And it's good to know, if you have all values of x, if you plug in 0, it's just going to be 0. You don't have to think about it, because, I mean, obviously, yes, you can still work it out if you want. But the more you start to see the pattern, like, I can automatically assume that, yes, it's 0, because if I plug in 0 for all of these x's, I'm going to get 0, no matter what. even if I subtract or add. So the y-intercept is just 0, 0, right? And then the x-intercept, or the zeros, actually, the zeros of this polynomial. So we have to do factoring, right? So we would do x times x squared plus 2x minus 2. Okay, now this one, I will not lie, this one is a pretty special one. So, because in reality, if we try to factor this using Xbox, so this one would be, so in reality, you'd have to do, I believe quadratic formula for this one. So the zeros would be at x equals 0. So be at x equals 0, and then you do, you can do the quadratic formula for the next part. So -2 plus or minus, and the quadratic formula is something that obviously you should already know. If you don't know it by memory, I would highly recommend committing it to memory, or practicing over and over again with it until you memorize it, because it's extremely important for calculus. So you would do -2 plus or minus square root of 2 squared minus 4 times 1 times -2, because of the quadratic formula, as we said, is -b plus or minus square root b squared minus 4ac all over 2a. So then you do all over 2 times 1, so it's -2 plus or minus square root of 4 minus 4 times -2 all over 2, and then you do -2 plus or minus square root of 4 plus 8 all over 2, -2 plus or minus square root of 12 all over 2, and then that's equal to -2 plus or minus, and you're gonna split it into 2 square roots. It's gonna be the square root of 4 times the square root of 3 all over 2, and then you're gonna say -2 plus or minus 2 square root 3 all over 2. This is equal to -2, and you're going to factor the 2 out, times 1 plus or minus the square root of 3 all over 2. And this would be, so basically you have x equals the negative of the quantity 1 plus or minus the square root of 3. So then this means that x equals -1 plus square root 3, negative the quantity 1 plus square root 3, or x equals negative the quantity 1 minus square root 3. So then you'd have x equals -1 minus square root 3, or x equals -1 plus square root 3. And these are your two x-intercepts. And if you want to go ahead and do that in decimal form, or like simplify that in decimal form, you can. But whatever it is as a decimal, you can put that, or you can just put this. It would be -1 minus square root of 3, 0, and -1 plus square root of 3, 0. Those are your two zeros of this polynomial. And it's also x equals 0 because we included x at the beginning, x equals 0, so it'd be 0, 0 as well. So the zeros are x equals 0, x equals -1 minus square root 3, and x equals -1 plus square root 3. Okay. I'm going really fast in this, guys. I'm trying my best, because I know this is literally review, so I'm not, this isn't as concerning. Like, it's something we should, something to just remember, like refresh our memory about. So basically, the next one, 320, is to simplify the following trigonometric expressions. Now, trigonometric functions are a huge thing of calculus. We're going to have to know how to do, especially once you get to Cal 2, you're going to have to know how to do, like, trig substitution, and you're going to have to know how to manipulate it using trigonometric identities. So yes, that is, we have to know how these work and how to simplify these so that we understand how they are, right? Now, so, okay, we have 320, which is, what is it? It's tan squared x over secant squared x, so plus cosine squared x, okay? Now, this basically, so the way we're gonna do this, we can do the following, okay? We can say, so we know tan squared x plus 1 equals secant squared x. So we can do manipulation of variables. Tan squared x equals secant squared x minus 1. So we can say secant squared x minus 1 over secant squared x plus cosine squared x. This gives us the following. So remember when I said x minus y over x is really just x over x minus y over x? That's what we're doing here. So we're going to do secant squared x over secant x, or secant squared x, excuse me, minus 1 over secant squared x plus cosine squared x over 1. And then you do, this is just 1, minus, and then 1 over secant squared x, that's really just 1 over 1 divided by cosine squared x plus cosine squared x over 1. So then this is going to be 1 minus 1 times cosine squared x plus cosine squared x. So it's going to be 1 minus cosine squared x plus cosine squared x. So it's just going to be 1 minus 0, which is just 1. Okay, that's how you do it. Okay. Number 321. There's two ways we can do this. We can prove that this is equal to cosine of 2x, or we can prove that, so basically we can simplify this into terms of sine of x, or sine squared x, or we can simplify it into terms of cosine squared x. So this can be either equal to 1 minus sine squared x, because this is cosine squared x, minus sine squared x, because remember the trig identities are cosine squared x plus sine squared x equals 1, so sine squared x equals 1 minus cosine squared x, and then cosine squared x equals 1 minus sine squared x. Okay, so then this would be equal to 1 minus 2 sine squared x, that's 1, and then also, this can also equal to, if we do, so basically we can do cosine squared x minus the quantity, and then we can do 1 minus cosine squared x, because that's what sine squared x is equal to, right? So when we distribute the negative, and we have cosine squared x minus 1 plus cosine squared x, this is 2 cosine squared x minus 1, because we combine like terms, and we just put negative 1, right? Minus 1. You can also remember that this is really cosine of 2x. Okay? But, of course, you can then say that cosine of 2x, and you can try to prove that that is equal to both of these. Okay? That's kind of how you do that one. It's a little, there's a few, like, there's more than one way to simplify this one. Okay, so it says solve the following trigonometric equations on the interval theta equals negative 2 pi to 2 pi exactly. Okay, so this one is, even though we briefly went over trigonometric equations, there's a way to do this, right? What you're gonna do, you're gonna go ahead and say that, so basically you have 6 cosine squared x minus 3 equals 0. And you can, if you want, divide both sides by 3, you get 2 cosine squared x minus 1 equals 0, right? Now, this one, so let me actually, hold on. So this one would be, if you do plus 1 on both sides, you get 2 cosine squared x equals 1, and then you divide by 2, you're going to get cosine squared x equals 1/2, and you do the square root, you're going to get cosine x equals plus or minus the square root of 1/2. Now this means that you're going to have cosine x equals plus or minus the square root of 1 over the square root of 2. So cosine x is going to equal plus or minus 1 over the square root of 2, which is equal to cosine x, which is going to give you cosine x equals plus or minus the square root of 2 over 2. So that means that cosine x equals square root 2 over 2, and cosine x equals negative square root 2 over 2, right? And then you're going to go ahead and say, for what value of x, so basically at what angle theta, if we say cosine theta equals square root 2 over 2, and cosine theta equals negative square root 2 over 2, what angle theta is going to give me an x value of both of these, where x equals square root 2 over 2, and x equals negative square root 2 over 2. In other words, at what angle theta does x equal square root 2 over 2 and negative square root 2 over 2, okay? And just to give you guys a hint, it's gonna be, well, this is if you're trying to do this on your own, but I believe it's gonna be 4 answers, okay? So if you look at the unit circle, we have the unit circle here, right? And actually, too bad it doesn't have ink to shape on here, but basically, let's just pretend that's the unit circle. So, there are 4 parts where we have, or actually, hold on. Yes, there's 4 parts. So basically, here, it would be, hold on, guys, give me a second. Okay, yes. So here we would have negative square root 2 over 2, comma square root of 2 over 2. This would be negative square root of 2 over 2, comma negative square root of 2 over 2. This would be square root of 2 over 2, comma negative square root of 2 over 2. And then this would be square root of 2 over 2, comma square root of 2 over 2. Because remember, this is xy, this is negative xy, this is negative x negative y, and this is x negative y, okay? We must remember the sign of each of the following, okay? In other words, it's very important that you know this. Hold on. So on the first quadrant, quadrant 1, cosine theta is positive, sine theta is positive, and then tan theta is also positive. Similarly, secant theta is positive, cosecant theta is positive. So that means if any sign that cosine, sine, and tan are, it's going to also be the same for secant, cosecant, and cotangent. So if cosine is positive, that means that secant is positive. If sine is positive, that means that cosecant is positive. If tangent is positive, that means that cotangent of theta will also be positive. We must remember that. And then for the second quadrant, here, cosine theta, which is our x value, that's negative because it's negative x. And then sine theta, here, that's positive y. That's going to be positive. And then tan theta is going to be negative. That means that secant theta is negative, cosecant theta is positive, and cotangent theta is negative. Okay, so let me actually finish this up really quick. Okay, so that is how it's done. Now looking at that, oops, my bad. Give me a second, guys. I don't know what happened. Hold on. Hold on, guys. Give me a second. Something happened. There we go. My bad. Okay, so that's how, basically, knowing all of these can help us, okay? Now looking at this graph, or looking rather at the, at this question here, at what angle theta does x equal square root of 2 over 2 and negative square root of 2 over 2? Now, we know that this is pi over 4, because like I said, if you remember the unit circle, this is pi over 4, and then that means that this is 45 degrees. So if you go to 90, you're going to do plus 45. If you go another 45 degrees over here, you're going to do, it's going to be about 135 degrees. Okay, so what is 135 degrees in radians? You're going to multiply times pi over 180. This is really just, so let me go ahead and try to work this out. Okay, so just think of this one as, so this one is pi over 4, this is pi over 2, but it's also 2 pi over 4. This one is 3 pi over 4, and then this is 4 pi over 4, or pi, right? And then this one is 5 pi over 4, and then this would be 6 pi over 4, or 3 pi over 2. And then this would be 7 pi over 4. So, the angle theta would be equal to the following. It'd be pi over 4. So pi over 4, and then, I'm trying to see, pi over 4, 3 pi over 4, 5 pi over 4, and then 7 pi over 4. So those would be your final, that's your final answer for that one, okay? And then this one, secant squared x minus 2 secant x plus 1 equals 0. Okay. That one's a little trickier, I'm not gonna lie. we're just gonna go ahead and skip it, only because, I mean, in reality, we can actually, well, actually, let's go ahead and solve it. So secant squared x minus 2 secant x plus 1 equals 0. Now let's pretend, and let's go ahead and try to make u equal to secant x, okay? Trust me, this makes it a lot easier. So the following is going to be u squared minus 2u plus 1 equals 0. This is a lot easier to solve now because it's in terms of u. However, the number one thing that I really want to emphasize and I really want to reiterate is that you have to make sure that you plug u back in for secant x. Or secant x back in for u, excuse me. So if you factor this, this is factored as u minus 1 quantity squared. And so this is equal to 0. So then you do u minus 1 equals 0. So this means that u equals 1. So that means that secant x equals 1. And we have to turn this into sine and cosine, right? So it'd be 1 over cosine x equals 1. That means that if we multiply both sides by cosine x, we get 1 equals cosine x. Now, so basically, at what angle theta, let's pretend that x is an angle, okay? Even though, yes, I know it's in terms of x, and we will put x equals at the end, but I really want to just put this as theta so that we understand that we are solving for an angle and not a value, okay? So, we know that theta, in reality, so if we look at the unit circle, this is pi over 2, pi, 3 pi over 2, 2 pi. And we want to know, where does cosine theta equal to 1? Well, in reality, it would just be 0 pi, right? Because we start at 0 degrees, or 0 radians. So theta would be 0 pi, 0, comma, and then you would go all the way around, and then back to, or actually, no, I'm right. You would go all the way around, and then you would go back to where x equals 1. In reality, this is the same as saying, at what angle theta does x equal 1? This is 1 comma 0, okay? So then you would say 0, and then you would do 2 pi radians, because it's not just 0 degrees, but it's also at 2 pi radians, because we can say that cosine of 2 pi equals 0. Yes. Yes. So, in reality, the answer is 0, 2 pi radians. 0 and 2 pi radians as your theta, or as your x. So basically here, x equals 0, 2 pi. Or 0 and 2 pi, really. Okay, so solve the following logarithmic equations. 324. So if we have 5 to the x equals 16. So again, how you're going to do this, you're going to go ahead and take the natural log of both sides. Okay. And then you're going to, so basically it's going to be the natural log of 5 to the x equals the natural log of 16. And you don't have to, like, round this with a calculator as long as you understand how it's solved. So really it's going to be x ln of 5, because you're going to move the power to the front, is equal to ln of 16. Now how do you solve for x? You're just going to go ahead and divide both sides by ln of 5. This is going to be equal to ln of 16 over the ln of 5. Okay. Okay, so, and then we have log base 2 of x plus 4 equals 3. Number 325. Log base 2 of x plus 4 equals 3. Okay, hold on. So what you're going to do this one, basically you're going to take, so, oh boy, how do I do this? So basically, you're going to go ahead and raise it to a power. So basically you're going to grab 2, and you're going to go ahead and raise it to the log base 2 of x plus 4 power, so that both sides have the same base, okay? And then you're going to do 2, and then you're going to just move the 3 back over, so it's going to be like this, right? That's so that they both have the same base. Now, notice that these 2 cancel out, so we can say x plus 4 equals 2 cubed. So you have x plus 4 equals 8. We subtract 4 on both sides, we get x equals 4. Okay, that's how that's done. Okay, guys, so, we're just gonna look at some terminology of, like, so that you guys understand and we remember what everything means, okay? The first part is an absolute value function. An absolute value function is, oh, and also, this is the last part I'm gonna go over. So, I didn't go over this, like, when we did, what is it? Like in Precal. I don't know if I did a video about it, but these are all the functions that we're going to be like studying in calculus more in depth as far as limits and derivatives go. So the first one is f of x equals x. This is the linear function, right? This is called a linear function. And this is all review. So, and then we have f of x equals x squared. This is the parabola function, the quadratic function, right? And then we also have the cubic function. This is so quadratic function, and then we have y equals x cubed. This one is like this, and we must know the limit of each. So the limit as x approaches infinity is infinity of f of x is infinity, and the limit as x approaches negative infinity of f of x is negative infinity. That's for this one, like both of them. And then for quadratic function, the limit as x approaches infinity of f of x is infinity, and then the limit as x approaches negative infinity of f of x is infinity. Okay. So the main idea is as long as you know the, as long as you know each quadratic, or not each quadratic function, each parent function, you can determine the limit, okay? So basically, or the end behavior, excuse me. And then the next one, I would say, I'm trying to think. The next one that I'm gonna do, this is sine of x, right? This one is f of x equals sine of x, even though I know it's not perfect. Let me go ahead and try to actually graph it very quickly. So let's see, sine of x, because I do know how it looks, obviously. It's just that, okay, yeah, I mean, it's pretty accurate. So, yes, this is sine of x, and then cosine of x. Cosine of x is more, cosine of x is almost the same as sine of x, but instead it's like, so it's like this. It looks kind of like this, hold on. It's a little hard to draw, but something like that, okay? Yeah, something like that. It's a little bit harder to draw because, so that's kind of how cosine of x looks. Okay, it's a little hard to draw, but if you graph it on your calculator, you'll know exactly what I'm talking about. So basically, I'm just gonna try it again. Hold on. It's something like this. Right, and then you do the same thing for the other side, which, something like that. Okay, this is y equals cosine x. Alright. And then there's tan x. So tan x just looks, it looks like this all over. That's how that is. And then cotangent x, or rather cosecant x, I'm just gonna try to sketch these as best I can because, yeah, it's a little bit hard. You don't really, like, I mean, you're not really gonna do limits of like, as x approaches infinity of these. At least I didn't do them when I was in what is it called, in Cal 1, so I don't think you would have to worry so much about it. But it's just so we know how the graphs look, parent functions. I will admit, cosecant x, like as long as you know how sine and cosine look, okay, I believe that that's good enough. The other ones, you won't, I mean, you will use them when you do derivatives and stuff, but like basically you won't do them like I'm talking about trigonometric functions. You won't like use them, or you won't be graphing them so much either in Cal 1. So the next one that I wanted to do, let's see, hold on. So e to the x, this is y equals e to the x. It's the exponential function, the exponential growth function. And then there's also ln of x, so natural log of x. Or actually, we can do log of x. Log of x, so y equals log of x. In reality, just looks like this. When we say y equals a to the x such that a does not equal 0, we can say that it can look like this. It's kind of like the exponential function. In reality, e to the x is just another power function. E to the x is just the same thing as saying y equals 2.71 raised to the x power. Okay, that's all that is. And then, hold on. I'm trying to make sure I go over all of them because I don't want to miss one. Did I do natural log of x or no? I don't think I did. Natural log of x. So natural log of x is kind of similar to log of x, but it just goes at a slower pace. So in reality, you would have something like, so like this would be log of x, and then let's see. This would be natural log of x, or ln of x. Okay. I'm trying to see if I'm missing more. The square root of x, y equals square root of x, looks like, how does it look like again? Oh, right. It looks like this, obviously. This is square root of x, okay? This one's square root of x. So you see how it's kind of like a curve, and it starts at 0 because you can't take the square root of negatives. So that's how that is. This is y equals square root of x. And then we also have y equals the absolute value of x, which you don't really use. You're not really going to use that in Cal 1 until you do integration in Cal 1, which yeah. You'll definitely do, especially when you're doing the integral, like the integral of like the absolute value of x minus 3 or something from 5 to 1, or not 5 to 1, but like 1 to 5 or something like that. Then you would have to then sketch it. You would have to sketch the absolute value. That's why it's really, really important that we did learn how to graph absolute value equations, because you will use those in Cal 2. Or no, in Cal 1, excuse me. So, well, also in Cal 2, because in Cal 2 you review that stuff. But basically, the absolute value is just this one here. Like this. It looks a lot like the parabola, or the x squared function, but it's straight. It's not a curve, it's straight. okay? And again, if you forget how to graph these parent functions, if all else fails, the best thing, or my best advice that I can tell you is to just do an XY table. Like, just do an XY table. And trust me, once you know Cal 2 or Cal 1, you'll understand how to graph more easily. Because especially once we get into limits. And also derivatives. I'm wondering if I already did all of them. The cubed root of x. The cubed root of x is, that's just the inverse of that's really just the inverse of, I mean, it's the inverse of negative x cubed, if I'm being honest. But, yeah, I mean, it looks like this. And then, I'm trying to think of another way. So, and then another thing is, remember that it goes, oh, how does it go? It goes x raised to the m over n power is equal to the nth root of x raised to the m power. We must remember this one, because when we are going to find derivatives of something like this, or let's say we want to find the derivative of the cubed root of x raised to the 7th, or actually no, the 7th root of x cubed, okay? We're gonna have to know how to convert that to this, my bad, to this. So that way we can not integrate, take the derivative more easily, okay? But we'll get to that once we get to that. And then we must know that ln of e equals 1 and ln of 1 equals 0, right? I'm trying to think of what else. I'm sure as we go along the book or whatever, or the practice problems, I'll definitely explain how it is. Because yes, you're gonna have to use algebra and everything that you've ever learned in previous math courses to understand everything in calculus. And then I believe that's it. And then the constant function is just this one, y equals c, where c is any number. So if I say y equals 3, it looks like this. It would look, hold on. It would look like this. This is at y equals 3, okay? And I believe that's it. I believe that's it. And inverse functions, remember inverse functions, basically, f inverse of x exists if and only if so if we have, for example, y equals 2x plus 3 and f of x equals 2x plus 3, we can say that x equals 2y plus 3. So yeah, I mean, I forgot the rule for it, the exact rule for it. Maybe it's in here. Yes, it says right here. For a function f, the inverse function f inverse of x satisfies f inverse of y equals x if and only if f of x equals y. Okay. And then piecewise defined functions, yes, we're gonna learn more about these in Cal 1. Like once we get into the limits from the left and right endpoints of a piecewise defined function. I'll go more over that in the that is what you do in the limits chapter. Symmetry about the x and y axis. That all of that means is so basically f of negative x equals negative f of x. That means that it is odd. So that means that it is symmetrical about the y-axis. And then f of negative x equals f of x. That is, or no, actually, hold on. This one is about the x-axis, excuse me. And then f of negative x equals f of x. That is only if it's symmetrical. And it's even and symmetrical about the y-axis. Yes. And also the line y equals x. Because if you think about it, for example, x cubed, that's an odd function because it is symmetrical about the y-axis here. And it is also symmetrical, like, what I'm trying to say is that, yes, it's symmetrical about the y-axis. That's what I mean. Just know that it's symmetrical about the y-axis. You don't have to know about this other part, because that's probably not true, but just know that it is symmetrical about the y-axis. Or the x-axis, excuse me. It's a little bit hard to explain about the symmetry part, but I do know that basically, even in odd functions you would do even if it's f of negative x equals f of x, and then odd if it's f of negative x equals negative f of x. So trigonometric identities, we already know what those are. Zeros of a function, that means that when a number x is equal to 0, such that f of x is equal to 0. Or actually, hold on. It's when it's whatever x equals when f of x equals 0, or whatever x equals when y equals 0. Okay. Composition of two functions, like I said earlier, that's just g, composite of f of x is g of f of x. The absolute value function is really just the piecewise function, negative x such that x is less than 0, x such that x is greater than or equal to 0. This is the point-slope equation of a line, which is y minus y1 equals m times x minus x1. Yes, they do this in Cal 1. You're going to have to do this in Cal 1 once you get to the equation of the tangent line at a point. So at a specific point, and I'm just gonna say this very quickly, whenever you have a curve, let's say you have some kind of curve, and they want you to find something along the lines of this. Okay? This is what we call a tangent line. Tangent line at x equals c, where this is the constant c, okay? This is the standard form of a line, and this is what the inverse is. We already went over that. So yeah, I think that's it, guys. I know this was kind of a long video, and I do apologize. I know I was trying so hard to go extremely fast, but at the same time, like I said, I really want to make sure that we understand everything. Now, if there is something that you are still like not good at, or if there's something in Cal 1 that you're struggling in because of the fact that you weren't good at it in algebra or pre-cal or trig, then it's always good to go back and review those terms, because they're very, like, the thing is that if you do not review, like, let's say I don't know how to do linear equations, I'm not going to be successful in Cal 1 because I'm not going to know how to find the equation of a tangent line, or how to find the equation of the secant line between the 2 points on a curve, or it's just really, it's going to be very difficult. And the thing is, we want to make sure, and for whoever is studying math or whatever you're studying in college and you're having to do Cal 1, it's very important that you at least have a very generalized idea of what algebra consists of, what trigonometry consists of, and if you know that, and if you know the basics of algebra and trigonometry, then you'll be very successful in Cal 1 and beyond, okay? So with that being said, guys, thank you so much for watching. In the next video, we are going to start with limits, okay? And with that being said, guys, thank you so much. And it's been an honor to, like, basically to make the videos of Algebra 1 all the way to this point, because now Cal 1 is basically, it's like the first class in where math actually gets very difficult. It's the first actual, like, college level mathematics. Even though I know college algebra, yes, they're college mathematics, yes, but Calculus 1 is actual, like, university level mathematics. So, with that being said, guys, thank you so much for watching, and I will see you guys next time. Bye, guys.